Nowadays, there are plenty of tools that we can use to solve the kind of system of linear equations that we are looking at here. The first way that we can do is that we can just use Wolfram Alpha, the free website or the app. So the command for that to be just solve. For example, if I want to solve this system of equation here, I can just go to their website and then type in solve, and then let's see, x plus y equal to 3 and x plus 2y equal to 5. I'm just gonna separate the two equations by the comma here, and let's see what we get. So then I get x equal to 1 and y equal to 2, which is what we got from earlier. If I want to try part B, so I'm gonna have x plus y equal to 3, and then 2x plus 2y equal to 5. And then it will tell me that there is no solution. And that kind of makes sense because if I multiply, so this one has no solution. If I multiply the first equation by 2, I'm gonna have 2x plus 2y equal to 6. But the second equation said 2x plus 2y has to equal to 5. So obviously 6 cannot equal to 5, so there is no solution here. Another way that we can do to solve this kind of equation is to use programming language like Python. So we have to call the package NumPy, and then the command for that is going to be linout. This basically is short for linear algebra, and then .solve. So let me pull up my Colab notebook, and then so let's see, I'm gonna have to import NumPy first. I'm gonna import NumPy as np. So let me actually zoom this a little bit. Okay, so then I'm gonna set my, so here let me actually go back. So my matrix A is going to be my right hand side matrix, and that is going to be 1 1 1 2, and then my matrix B is my vector B is going to be just the vector 3 5. Now to type in this matrix in NumPy, I'll just take that as a NumPy array. So my A is going to be np, so that's NumPy.array, and then to type in the matrix, I'm gonna have to put that inside a bracket, the round bracket and another square bracket, and I'm gonna need to input that row by row. So my first row is gonna be inside another square bracket, and that's gonna be 1 2, and for my second, my first row is gonna be 1 1. So my first row is 1 1, and then my second row is gonna be inside another square bracket, and that's gonna be 1 2. So that is my matrix A. And as for my vector B, that's gonna be another NumPy array, so that's gonna be np.array, and then my vector then is gonna be just 3 5. Notice how it's a little funny that I need to have like two sets of brackets here. So if I want to solve for x, the command for that, my x is gonna be numpy dot. So the command is again is linout, that's linear algebra dot solve, linout dot solve. And then I'm just gonna input my matrix A and B here, and let's see what I get. So there we go, but it doesn't give me anything because I doesn't tell it to show me the x. So now let's see what we get. Okay, so there's my vector x, which is what we are looking for. So my x is gonna be 1 and my y is gonna be 2. Now let me try the same thing with the second example. So now my matrix A is going to be 1 1 and 2 2. My vector B is going to be the same, but if I click run this time, then it will run into an error. So one disadvantage of Python is that if there is a problem with my system, like what we have here, if there's no solution, then this linout.solve will run into an error. We're going to talk about how the workaround with that with the next example, but for now, let me move on. If I want to do part C here, x plus 2y plus 3z equal to 0. So let me try Wolfram first. So I'm just gonna have x plus 2y plus 3z equal to 0. And let's try to run that. Well, so this should be pretty simple. Yeah, so my y and my z is gonna be the free variable, and then my x is gonna be dependent. I just move 2y and 3c to the other side, and that's gonna be my x. So if I were to construct the augmented matrix for this, that's gonna be just 1, 2, 3, and then 0. So my x here, this is gonna be my dependent variable. This is gonna be my dependent variable. And then my y and c here, this is gonna be my free variable. But I like to notice that sometimes the free variable and dependent variable can kind of switch place as well, because one way that we can write a solution to this is x equal to negative 2y, negative 3c, right? So my y and z is free and then the x is dependent. But I can also kind of do it this way as well. I can just say 2y is negative x and then minus, let's say 3y. In other words, I mean 3z. In other words, my y is going to equal to negative x over 2 and then minus 3/2 of c. In other words, I can kind of switch role here. I can actually let my x and my z to be a free variable. And then my y here would be a dependent, would be the dependent variable. Or I can do the same thing with c. So my 3c is going to be minus x minus, let me see, 2y. So my c is going to be minus 1/3 of x and then minus 2/3 of y. So once again, whether the variables are free and dependent, sometimes that can be changed. It depends on how you write out your equation. So here my x and my y are going to be free variable, and then the c here is going to be the dependent one. Okay, let me actually write it. Dependent one. Okay. Now, if we try to solve this using Python, let me actually just change my code a little bit. Let me go to my Python. Okay. So let me just copy and paste this into another cell. Okay. So my matrix then is gonna only have one row, so it's gonna be just 1, 2, and 3. And then my vector b is just gonna be 0, and if we can click solve. Yeah, so once again, Python cannot handle the system where there are infinitely many solutions, so it runs into an error. Now for the last one, let me try to do that in Wolfram then. So the equation that we're gonna have is, let me see, so I'm gonna have x1, I'm just gonna type x and then 1 here, plus 2x2 and then plus x3 and then 3x4 equal to 9. And then the second equation, let me also zoom in on this one, so it's a little easier to see. Okay, and then I'm going to have 3x1 plus 9x2 minus 3x3 plus x4 equal to 0. And for the last one, I'm going to have 2x1 plus 5x2 and then plus 7x4 equal to 20. And let's see what we get. Yeah, notice how Wolfram actually understands my x1, x2, x3, and x4 here. So it knew that I don't mean x task for it. So it treats each of my variables as a different variable. So hopefully I didn't make any mistake here. But this is what Wolfram told me. So I'm gonna have my x1 and x3. Wait a minute, so the outcome that I get at x2 is gonna be this chunk here. So x2 is going to be a dependent variable and it depends on x1, and my x3 is going to be a dependent variable and that depends on x1. But like I said earlier, whether or not the variables are free or dependent, that can change, and my x4 is going to be fixed at 3 here. For now, let me actually go ahead and write this down. So let's see, my x2 is going to be negative 2x1 over 5 minus 1/5, and then my x3 is gonna be 2/5 minus x1 over 5, and then my x4 is gonna be 3. So my x1 here is gonna be the free variable, so my x1 can just be anything. Let me just say x1 equal to x1. And let's also try and see what's gonna happen if I were to run this in the Python. So let me once again just copy my old code. I actually no longer need import numpy as np here because I actually already import that when I run it the first time. So let me actually just delete that from here. So I'm just gonna simply copy this thing and then paste it here. So my array now, my matrix A is gonna be 1, 2, 1, 3 for the first row. My second row is gonna be 3, 9, -3, and then 1. And then let's see, my third row is going to be 2, 5, 0, and then 7. And for my vector B, it's going to have 9, 0, and 20. So I'm gonna have 9, 0, and 20. So let's see what happened. Yeah, so once again, it got into trouble, and that's because the system that we are looking at here have infinitely many solutions. So we're gonna talk about how we can work around this in the next example then.